drop
and
it
we'll
and
move on.
Okay. Now let's look at continuous variables and interactions and curves using continuous variables. This is some really cool stuff. So the next chapter. And we'll go through this, I think, well, we'll see if we finish this today, or maybe we'll not quite finish this today. It's pretty straightforward at this point, once we've kind of covered the kind of what interactions are. And so far we've talked about interactions where we have looking either at two categorical variables, where you just multiply every dummy variable here with every dummy variable there, which if you think about it, let's say you've got two 4-level groups, race, ethnicity, and then type of school. So maybe each of them are 4 categories, so you got 3 dummy variables. So your interaction is going to be 3 times 3 is 9 variables in your interaction. If you ran some ANOVAs where you've done that, and you notice, take a look back at the degrees of freedom, and you'll notice like some of those interaction terms can be a lot of degrees of freedom if you're dealing with a large number of groups. But so far we've talked about where it's the 2 categorical variables or 1 categorical variable and a continuous variable, but you can also do interactions with 2 continuous variables. And it really operates exactly the same way. Nothing's really changed. That's why I think this is pretty straightforward. The kind of the standard approach, or often, what people do is you may want to center your continuous variable, particularly if if the 0 has no inherent meaning. 0 might be useful, but you can, again, particularly if 0 has no inherent meaning, you may want to center. Again, it won't change the overall effects, just what the coefficients are testing, because now you're not talking about predicted scores at zeros. You're talking about predicted scores at the average of whatever those continuous variables are. So the coefficients will change, their p-values will change, but the overall effects will not. You then create a new variable based on the product of those 2 continuous variables, so you multiply them together, create a new interaction term just like before, and then you enter that as a separate step after the main effects themselves, just like before. Let's go through a quick example. I want to look at GPA, college GPA. One predictor is anxiety on a 25-point scale, where higher scores indicate anxiety. And the second variable is hours worked per week, 0 to 40, and then the interaction. In this case, I'm not going to center them for whatever reason. And we need to create our interaction term. Here's our descriptive scores. If you want to center so you can get the means for work and anxiety, in case you do want to center them, make sure you go to the, well, anyway, if we're going to center them, so let me take a step. So we start with these variables. Let's look at the mean, let's look at the averages for work and anxiety so that we can center them. So that's, make sure you have to get the means if you're going to center them. And in this case, if we are going to center them, let's create we have to make a new variable, work underscore C and anxiety underscore C for the new centered variables. Each of them we just subtract the average. That's all we do for centering. Subtract the average from work to make the new variables. Always save the original, just in case. Don't just overwrite your old variables. Always save the original variables. Yeah. We create our interaction term, where now we're multiplying the work centered by the anxiety centered is our new interaction, and I'm calling it angst work. We're going to do a multiple regression. In this case, we're just going to do 2 steps. that we're entering work and anxiety, because we're entering work and anxiety in one step, and then we're going to enter anxiety, the interaction, as a second step. So it's kind of that example of a simultaneous regression, but where we're still then adding one step to test an interaction that we talked about. You may often do. If we look at our model number 2, where we've added the interaction, the overall model is statistically significant. We had 322 kids, or students, I should say, and with 3 and 318 degrees of freedom, our F was 67.499, our P is less than 0.001, so the overall model is significant. If we look at the model summary, that overall model accounts for 38.9% of the variance in GPAs. And the test for is that significant, right? That was the ANOVA just told us that 38.9% is significant. If we want to look at the interaction term, the interaction accounted for 2.4% of the variance over here in the change statistics. So of that 38.9%, 2.4% is related to the interaction, which is significant. With 1 and 318 degrees of freedom, our F change was 12.664, P is less than 0.001. Here's our regression model. 2.753 minus 0.029 times the centered work, minus 0.018 times the centered anxiety, minus 0.001 times anxiety times work. Now, this is notice that's a really small number, which can be a problem sometimes in the sense that you may need to actually click on these and open it up or go beyond, find some way of increasing the number of decimal places it reports to get so it's not so rounded in this case when you're doing the analyses. And that's because remember, we're multiplying terms. So if you have 40 hours a week and 25 on the anxiety score, well, even if you've centered and it's 20 and 12, that's a big number, 360. So the interaction terms can get very big. The values for that variable can get very big, so the regression coefficients get small as a result. So don't look at it and immediately think, oh, that's really, really tiny. It may not be. It's just because these values have gotten very large. So a 1 unit increase on something that goes from like negative 200 to positive 200, it's a small, that's a small little tiny step along a very big scale. So don't be deceived into thinking, oh, that's nothing. Graph it and find out. So now, because we've got to continue, when we had categorical variables, it was pretty easy. Well, let's draw a line for males and let's draw a line for females. So that was pretty easy. We naturally knew kind of which values to start plugging into the regression equation to graph. But with continuous variables, what we have where they're both continuous, how do we pick a number? I mean, 0 and 1 doesn't make sense because they may not even be meaningful numbers like we did with. We could do that when it's a dummy code, but in this case, it's not. So one common strategy that people will do is you pick one of the variables. You've got two continuous variables. Pick one variable that you will graph across the entire range, and one variable that you're going to create a high and low of, or maybe high, medium, and low, and you're going to graph that variable. You can, if you've got the software and the visual skills, whatever, you could create a plane and graph them, in something like or some other software. But if you're just making kind of a simple two-dimensional graph, this is typically how people will approach it. So select one predictor that's going to be the x-axis, and then the other variable is going to be drawn as is going to be a line of high, medium, or low. And often how we'll do that is pick one. You're going to graph the regression line for one standard deviation above the mean on that variable, at the mean on that variable, and one standard deviation below the mean on that variable. So kind of looking at here's our variables. Let's say that I'm going to graph hours you work a week. That's kind of a clean one. How many hours you work every week on my x-axis. And then I'm going to draw based on, we're going to come up with 3 lines based on high, medium, and low levels of anxiety. So let's look at this. And so here's our scores. Now notice here I'm looking at the non-centered values just to kind of get it, because it'll may be more intuitively easy to read 0 hours working a week than minus 12 hours working a week. But in this case, so the hours worked was 0 to 40. The centered values were -10 to +29. For anxiety, centered, well, we know the average for the centered anxiety is 0 because we centered it. And one standard deviation above the mean is going to be, well, what's the standard deviation for anxiety? Oh, there it is, 5.9. So being I've centered anxiety, one standard deviation below the mean for anxiety is -5.9. The mean anxiety is 0. And one standard deviation above the mean on anxiety is +5.9. So let's go back to the regression equation. Here's hours worked in the uncentered values. Here's what that translates to in terms of centered numbers that I'll be plugging in for work. And let's say if I did 0 hours, 10 hours, I'm just kind of going to I'm going to calculate a few different values to come up with what my line might look like. Kind of step back a sec. So here's the regression line. Here's the regression equation. And I want to plot from 0 to 40 hours a week on my x-axis. To do 0 to 40 hours a week on my x-axis, that would be from -10 to +29 centered work hours. And this equation is based on centered work. So I need to plug in, I can't plug in 40 hours a week, I need to plug in 29.24 into this equation. And then we know for anxiety it was -5.9 or +0 or +5.9 based on, my low, medium, or high anxiety. So using this centered value, and let's say the -5.9 for the low anxiety, let's calculate predicted GPAs for someone whose anxiety score is -5.9. And if you work 0 hours a week, well, that's the centered value of -10.6. So you just start with 2.75 minus 0.29 times -10.6 minus 0.18 times -5.9 minus 0.01 times -5.9 times -10.76, and you get a predicted GPA of 3.11. So we're doing it the same way, but notice we're plugging in the values. It's a little kind of complicated keeping track of its centered range. But we're doing 3 regression lines now instead of just one, and we're picking the values based on the standard deviation. It's 1, -1, 0, or +1. And then you could do 10, 20, 30, 40, kind of get a range and then just graph this in Excel and have connect the dots to make nice little straight lines. If we plug these in, so we first do work centered, and these are the results we would get based on anxiety of negative 5.9 with work, if work is 29.24 and anxiety is negative 5.9, and you plug this in, you get 2.19. And so you can see with low anxiety, your GPA goes down as you work more hours. Average anxiety, so now we're plugging in zeros for anxiety. That actually makes it kind of easy because this is going to drop out, and that's going to, because right, 0 and 0, all that's going to drop out, and it's just going to be this. We plug in the work values with zeros for anxiety, and you get these values. And then we do the exact same thing with positive 5.9 for anxiety, and we do negative 10.76 for work, positive 5.9 for anxiety, positive 5.9 for anxiety, and negative 10.76 for work, and you get 3.02. And at the very end, if we did for the working 40 hours a week, we put in 29.24 for work, positive 5.9 for anxiety, positive 5.9 for anxiety, and positive 29.24 for work, and you'd end up with 1.62 for the GPA if you're high anxiety working 40 hours a week. And you can look at those numbers and start to try to make sense of it, but like we said, it's always better just to graph it. So here's a graph, and simple Excel, SPSS will do some of these. SPSS graphs have gotten better over the years. They used to be hideous for the longest time. You could just look at someone's paper and it's like, I know it's kind of the generic crappy SPSS output, but it's gotten better. But this is an Excel, and all I did is I just plugged, like I said, you can just plug in some values and then just it connects the dots. So we see for low anxiety, everybody's grades go down the more hours they work. Bummer. Not rocket science. But they all start off pretty similar. If you're not working, low, medium, or high anxiety, GPAs are all right about the same. But as you work more and more hours, what happens? You see more and more variation between the grades. The higher your anxiety, the more your grades suffer with extra work. If you're not working, it doesn't matter. You can be high anxiety, low anxiety, and your grades are exactly the same. It just goes down more. It's harder. School's harder on you if you're higher anxiety, or at least your grades are lower. Okay? So that's a continuous that's two continuous variables where you're trying to make where you have an interaction between two continuous variables. Again, to kind of illustrate it, one variable, pick one of them to be this continuous variable along your x-axis, and then do 2 or 3 lines for the other variable based on, again, often one standard deviation above the mean, and one standard deviation below the mean. Now, it may seem kind of funny to talk about curvilinear effect.